Okay, let's get started. Thank you very much for coming to this Introduction to R and Statistics module. So my name is Laurent. I'm a professor of bioinformatics at the UC Louvain in Belgium. And I like R, and I like to share my enthusiasm with R. So my name is Laurent, and I'm here to try to get you to like R. Right? Like is probably something very different than what you're used to use. But I think there are really nice aspects, and it's really possible to get lots of fun with R. And I'll try to share this joy of R with you. I hope it will work. And before we dive into the technology, I would like to show you another piece of technology that I find extremely, extremely helpful when I teach. Or when I do the grocery, and these are these sticky notes. So I see you already have green sticky notes, all of you. That means that you have working computers, I think. But I would like you to also take one red sticky note each. So could you take one and pass it around? Please don't hesitate to remind me if my voice goes down. And so we are going to use these sticky notes. Oh yeah, and by the way, so you have a green and a red sticky note, but I will probably call your red sticky notes orange and possibly your green sticky notes blue. But you have to understand that for me, orange and red is the same, and blue and yellow. You see, yellow, blue and green are the same, okay? So we have one color, this one, green, that says good. Okay, Laurent, you're doing a good job. We like what you do, and you can go on like that. And then there is this other color that says, Houston, we have a problem. That means we need to stop. You have a question, or there is something that is not quite right, and we need to take time to address what is not quite right. Now, of course, you're also more than welcome to raise your hand and call me or call one of the TAs if something is not quite right. But sometimes people feel, embarrassed to call out. And so you can also use the sticky notes to signal that there's something not quite right with the code, with your computer, or whatever. But there is a second use case for the sticky notes, is that maybe not that much today, but much more tomorrow. The point here is not for me to speak for a day and tell you how great R is, but the point is for you to experience this joy of R, right? To do exercise yourself. That's the best way to teach yourself R. And so when there is an exercise, and that's extremely important, I will ask you to use the OK color, so green or blue, and paste it like this on your laptop when you are happy, when you have finished the exercise, or even if you haven't finished the exercise, but you know that it's fine, you're happy to move on. However, if you have a question, something is wrong, you would use the other color and paste it like this to tell us that there is something, that there is a problem with the exercise of the computer, or maybe you haven't understood the question, or you struggle with finding the answer, and then we can come and help you. But it's extremely important that if we suddenly see that there are, 5, 10, 15 red sticky notes that pop up, we realize that there is something wrong. Most likely I didn't explain the question well, or maybe I didn't explain the R part to solve the question well, and we need to step back. On the other hand side, if I see that there are tons, 90% of people have their green sticky note up, I know that it's probably a good time to move on. Or maybe I can go and ask a couple of people that haven't put their green sticky note up, and it's probably because they forgot to do it. But it's good to kind of pace and not waste 10 minutes wondering have they finished or not. Okay, so they are really useful, so try to use them. Okay, so all the material is available online at this URL, Gatto, that's my username, .github.io, May Institute RStats Intro. Okay, and here, so this is the material online, and it will stay online for the foreseeable future, forever, whatever that means in terms of something being online. In addition to that, you can also download the whole teaching material as a PDF. I think there are about 120 pages or so. But the material is written so that it renders online. I'm not quite sure if everything renders well as a PDF, but it's there as a record for you to kind of take with you back home. And so we also have some data that you can download here on this first link. And actually, the PDF and the data are also available on the Google Drive. Have you heard about the Google Drive? So these are the same files, except maybe that if I happen, based on your questions, to do a couple of changes to the material, the link to the PDF here will update automatically. Maybe not on the Google Drive, although I'll probably do it at the end of the third day. Okay. So any questions before we really get started? Okay. All right. So the goal of this first day is to familiarize yourself with R itself, so the kind of the language R, the syntax of R, and another piece of software that we are going to use to interact with R called RStudio. And then, familiarize yourself with the syntax and then start to write a little bit of R, write R code, or write scripts that contain R code. Really, that's the point. And then tomorrow, we'll start to do actual data analysis, slightly more kind of complicated data analysis. So why learn R? I think, in the lecture notes, I have why learn R, and then some of the reasons why to learn R. I know why to learn R, but I'm wondering, why do you want to learn R? Is anyone willing to? I'm generally picking up people at random, so yes?
Just better data visualization.
Visualization, excellent point. That's one I have on my in my notes. Good visualization, yes?
And then the statistics.
The statistics, yeah. That's probably the first reason. R is originally a piece of software to do statistics. It was developed by two statisticians, Robert Gentleman and Rossi Haka. And they developed this piece of software because they needed something to teach statistics. And the software they used before that was called S. But it's a commercial piece of software, so they thought, oh, well, you know what? I'm going to develop my own clone of S, call it R, obviously, called Robert and Ross. And that's how it started. And yes, it's a piece of software for statistics that supports visualization, but actually it's much more than that. It's used for high-throughput biology, but it's used in academia, in industry, at Google. So it's a piece of software that is used across many, many domains. But we are going to focus on kind of data analysis and simple statistics in this course. And other reasons why you are here to learn R and statistics? What about the interface? How do you interact with R? Command line, yeah. So is that a good reason? Is that a good reason to learn R? Do you think using the command line is a feature or is it a bug of the software? Anyone? Well, I certainly think it's a great feature. I think every piece of software should be command line. No, of course not. But if you want to do data analysis, an extremely important point of being able, or when analyzing data, is to be able to reproduce that analysis myself later on, maybe with different data, or allow somebody else to repeat the analysis I did. And if you have a command line interface, if you write a code, you type commands to analyze data, by definition, it's reproducible. I only need to give you the script that I wrote, the lines of R code, and you will be able to reproduce it as long as you have the data. So having a command line interface is something extremely valuable. But of course, it has a learning curve. I also have here, R has a large community. and that's true. Lots of people use R, not only in academia, not only for proteomics. And this has notable benefits. Lots of people can contribute their expertise in R. Not only statisticians, not only programmers, not only data scientists, but also biologists that have their domain expertise, and they can contribute to R to develop an R package, a dedicated piece of R code to analyze biological data, for example, mass spectrometry data. Right, but we are not going to use R directly. We are going to use another piece of software called RStudio. So I'm going to start RStudio here. Did it not start? Yeah, RStudio. And I would like you to start your own RStudios on your computers and put your green sticky notes up if you succeed. As a first sticky note test. I'm already worried. Mine takes a little bit too much time to start. So I need a red sticky note. No, okay. Right, here we are. And let me just change up. Do you have the same screen? Does it look the same thing for you? Yeah? Okay, very good. So I'm going to ask you all to click on the very first button, top left, the little kind of plus with a sheet, like, and then select the first one, R script, just so that we have the 4 panels, and I can explain a little bit what these 4 panels are. Okay, so that's RStudio, and that's what we are going to use throughout these 2.5 days. And so these 4 panels have different purposes. And maybe the 2 most important ones are, firstly, this one that says console here. So we have other tabs, but they are not so important here. And the console here, that's actually R. Okay? So that's the R piece of software. When you start R, it gives you a little welcoming message. And then there is the cursor here, and it waits for us, or for you, to type some R code. And we're going to do that in a minute. But we have additional panels. The one here on the top right is one where we can browse our files. We're going to use this in a minute too. But that's also the panel in another tab here where our plots will show up. For example, tomorrow we'll learn a little bit about visualization, and the plots will also show up in this panel. We have another one here with the history of everything we type is kind of recorded, only recorded for the duration of our session. And then we also have here this one, the environment, and that's all the stuff that we are going to create will be listed here. And then we have this one, and that's where we can write code. Okay? So we can also write code here, but the code that we write here is only displayed in the console. It's executed by R, but if you want to store something, we would want to write it here in a file. Okay, and so that's what we're going to use. So I'm going to change this layout. You are free to do whatever you want, but I'm going to change it because it will be difficult for you to see if I type something here at the bottom. Okay, and the 2 most important panels is this one and that one. Okay, so for start, I'm going to change this layout, and there is a button here, and then I can say here, pane layout, and I'm going to have on one hand side the source, and the other one the, oh, okay. I need to restart our studio to change this layout. I'm not quite sure why. So I want to have the code that I write here on the one side, and then R itself on the other side. And I want these to be at the top, so it's easier for you to see what I do. But that's really the only reason. Feel free to change this if you wish so. Okay. Okay. But before actually we get started with R, we're going to learn a little bit about project management in R and RStudio. When you start data analysis, whether it's a very small and simple one or something much bigger, let's say you have, I don't know, 100 MS acquisitions to analyze, when you start your data analysis project, it's a little bit like when you start an experiment. It's important to somehow plan what you're going to do. Okay. Before running your experiments, you think about your experimental design, and there are kind of similar best practice to have when you start a computational project. And so we are going to do this with RStudio that provides some functionality to do that. And so if I open here my file browser, by default, I'm in my home directory or my kind of my document directory on Windows or home directory on Mac and Linux. Okay? And so the directory that you see here is called your working directory. Okay? That's the directory where R kind of is and is expecting to find files. Okay? And so if we want to find a file, for example, in this custom office templates directory, we would need to tell R, fetch that file or read that file that is in this directory. Okay? So R expects to find things in a working directory. And so we're going to start by creating an R project or an RStudio project, and we can do this by clicking on File and then New Project. So I invite you to do this, and then we get this little kind of wizard that asks us what kind of project we want to create, and here we will choose the new directory. Okay, so our project, all the code, all the data, all the outputs that we will generate will be stored inside this new project directory. New project, and then there are kind of a set of types of projects that we might want to create, and here we'll use a kind of a plain new project. We could develop an R package. That's what they are going to do on the other room. Kind of shiny web applications. We are going to do a kind of a plain R project that lives in a directory. So what we need to do is to give it a name. So I'm going to call this R intro. And I also have to specify in what directory I want this project or this directory to be created. And I'll just leave it to the default here. The little tilde means my kind of home directory, my documents on Windows. So I will simply click on Create Project. And so now this RStudio session is going to restart. But as you can see here, now the R working directory is inside my project. Okay. Home, R intro. That's the name I gave to my project. And now the new working directory for R is this one. Okay. So what I'm going to do is throughout the 2.5 days, I will always work in this project. Okay. So at the end of the day, I'll shut down RStudio, and first thing tomorrow morning, I'll start RStudio, and I will reopen my project and store everything I do, all the code I write, inside this project. Okay, so have you all created your project? Yeah? Okay, very good. So currently our project is empty. File that is not very important. That's a file that RStudio uses to kind of manage their projects. But we're going to create some content. And maybe the first thing we could do is create a new folder by clicking on this new folder button. By the way, we are doing this within RStudio, but we could create these folders and these files outside of RStudio. It's just handy to do everything in RStudio. So I'm going to create a first directory that I'm going to call data. And maybe I'm going to create a second one called figs for the figures. Tomorrow I'm going to produce figures, so maybe I will want to store my figures in there. And I'm going to briefly switch to my lecture notes and scroll down and show you an example of a project structure that you might want to choose. Now, this is really up to you, but that's the kind of directories that you might want to create whenever you start with a project. So here we have the working directory. That's kind of the main directory that contains our project. And then there is data. That's where we are going to put our data, okay, the raw data. And by raw data, I don't necessarily mean MZML files, but any kind of starting data that we have, we are going to put there and not touch. Okay, that's like a read-only directory where we're going to read the data, but never, ever modify that data. If we need to modify it, then we create a copy, and then we can modify that copy, but never, ever modify that kind of original data. And that original data would come here into data. And that's very handy because if I need to read my data, I will use a command in R to read my data. And there will be different commands depending on the kind of data that we want to read. But I will know that I will be able to find my data in here. Okay? So fig output, I call it figs. That would be a directory where I'll store all my figures. Maybe a directory documents if I have, I don't know, slides that describe the project a little bit, experimental design, I could put in here. We will be also generating data, kind of subsets of data or data after processing with p-values and so on. We might want to store these into data output and maybe even a directory with scripts where we will kind of store our R scripts. The point here is to highlight already now, it's the beginning. We haven't written anything, but it's really useful to think about your project and your project structure right at the beginning, just as you would think about your experimental design before generating data. By the end of the course, we will probably have, I don't know, 10, 20 files that we will have produced in the course of 2.5 days of an introductory course. So imagine if you have a kind of really big, complex project, you might easily end up with, tens of files or hundreds of figures that you produce. So if you don't start with managing the project, at least that's my experience, it ends up being a huge mess. And if I finish working on Friday and then Monday I come back and I look at my project and I have no idea where to find what if I'm not structured from the very beginning. Okay. So I'm going to, let's start. Let's start a little bit with R, and then I'll talk about the other stuff later. Yeah, maybe I'll get back to that later. Okay, so I'm going to minimize this window and come back here in R. So we can start by using R like a giant calculator, right? 1 plus 2, and R will do this calculation for us. And it will print a result on screen. Now, 1 plus 2 is a pretty trivial calculation, but imagine it was not. Imagine that 3 here was a really important result. The problem is that kind of 3 is printed out in the console, but it's not stored anywhere. So how do we, in any programming language, how do we store values? Well, we create variables. Okay? Variables is a kind of a reserved space in the computer to store data. For example, 3. And so let's imagine I want to store 3 in a variable that I'm going to call x. And I can do that by first saying x. Here's a variable. X doesn't exist yet. And then I can use this left arrow. So it's a smaller than sign with a minus. And then, for example, 3. Enter. And actually, what you can see here in my global environment panel, I see that x has appeared with value 3. Okay. So what happened here is that I created this new variable. It was not present here, and I assigned to it number 3. So that if I now type x again, I can retrieve this value. Now again, this probably sounds terribly trivial, but imagine that the value that you store in x is the result of a long calculation that takes 5 hours, suddenly storing a value in a variable doesn't seem that trivial anymore. Okay? And now we're going to start with single values, single variables, but imagine you have 10,000 proteins, you run 10,000 statistical tests, you get 10,000 p-values, you want these to be stored somewhere. And they would be stored in a variable. So we can override, oh, by the way, so this assignment operator, kind of the arrow pointing to the left, you can type smaller than and a minus, but you can also type add minus, and it will automatically produce this sign towards the left. Yes?
If you mistakenly type something, how to remove?
For example? Okay, yes. Very good. So let's imagine I want to update the value in x and update it to 5. And I start by typing x, assignment operator, and then enter. And you see that now I do not have my greater than sign. Greater than sign means R is waiting for us to do something, but we have the plus. The plus means that R knows that we are not done yet. X assignment does not make sense. It's not over. It's like if I say, tomorrow I'm going to, right? You know there is something coming. And the plus means this. The plus means R is waiting for you to type something. So I can carry on typing my command, for example, 5, enter, and then as you can see, R switches back to the greater than sign. It means, yes, you have finished typing your command, and indeed here we can see that the content of X has been updated to 5. Yes?
Is there a difference in R syntax between using an equal operator versus there?
In 99% of the cases, no. So we could also type X equals 10, enter, and that works too. So, yes, good. Don't hesitate to remind me to repeat the questions. The question was, is there a difference between an equal sign or the left arrow? And in 99% of the cases, it doesn't matter. So pick your camp. Are you an equal person or are you a left assignment person? Yes?
My question is, but wouldn't that sign mean to initialize that variable when, if you're using a conditional statement, you'll be assigning that x variable to a number?
No, you assign the number to a variable. So the variable x is like a drawer. The computer memory is like a huge shelf with tons of drawers. And when we start, they are all empty. And what just happened there is that I labeled one drawer with X. I opened it, and I put the value 3, and I closed the drawer. And then I updated 3 to, what was it, 5. I opened my drawer. I removed the 3. I put a 5 in. I closed my drawer. I did it with a 10. And so, for example, if now I say y is 1, this means that, oh, I have another drawer, and we have millions and millions of drawers. Okay. The number of drawers depends on the memory that we have on the computer. There is an empty drawer. I label it with y. I open. I put a 1, and I close. So that's, what figuratively, that's what happens.
When we storing this type of variable, are we storing it in the RAM memory?
Yes. Yes, it's in memory in RAM. Yes. So yes, equal sign or left sign operator, it doesn't matter. My only advice is pick your battle and stick with it. Do not change from equal to left operator, because that will be confusing if you need to reread your code. Yes?
Sorry, this is a lot of questions in the same
Good.
context.
Thank you. When I teach, I always bring lollipops. And so the first students, I forgot lollipops today, I'm sorry. But they are younger, little children. So the good questions, the first questions and the good questions get lollipops.
What was that 1% when that doesn't work?
Maybe I'll tell you later. No, and if I tell you now, it won't make any sense. It's in function arguments. So maybe we'll see it later. But it's in kind of edge cases that you'll probably not apply at this stage. Yeah, it's really kind of exotic use cases. We are unlikely to stumble upon these exotic use cases here. Okay. So we have seen how to, something else useful. We can use the up arrow, up arrow key to go back in history. You see? So if I typed x is assigned 3, I can go up a couple of times until I have x assigned 3. So I told you, yeah, command line interface is nice, I like it. But of course, to make it enjoyable, we need to know a couple of keyboard shortcuts, right? So up arrow is one of these to make our life easier. So of course, being able to be good at typing helps. And we'll see other keyboard shortcuts that will make our lives much easier. So far, what we have done here is to write R commands. This is R code, but we have written it in the console here. So we can see it, but if I type CTRL L to clear my screen, we cannot see it anymore. So of course I could go up, but that's not very helpful. So we want a way to make sure that all the code that we write, we can see and we can reuse. And to do this, we are going to write an R script. So what I'm going to do is that instead of typing everything in my R console, I'm going to write it in an R script. And so I'm going to, like we did before, click here on the little plus and create a new R script. And so here, this is a new file that is opened. And the first thing I'm going to do is I'm going to save it. So let me also open this panel here. So that's my working directory. So currently I only have 2 directories, data and fix. So I'm going to save this script, Control S, or surely the little diskette here, little disk. My young students have no idea. They know that if they click there, something happens, but they have no idea what a disk or diskette is. So you can click here. I'm sure some of you know what it is. Or Control S, or probably even File, Save, yes. Okay, so Control S, and I'm going to start by saving this script, even though it's empty. And by default, it's going to be saved in my working directory. And so I'm going to call it S01 start R. So the R scripts generally have the R as extension, either capital R or lowercase r. Again, pick your battle and then stick with it. I'm going to use a capital R. And so here it is. Now, S01 start R is my first R script. And so from now on, so have you all created your first script? Feel free to call it the way you want. Oh, by the way, yes. I tend to call my scripts S01, and then later today or tomorrow, the next one will be called S02, S03, and then when I hit S09, the next one will be called S10, and that's why I don't call the first one S1, because suddenly I arrive at S9, and the next one is called S10, so I start with 2 digits, unless I know it's going to be a really big project that I could start with S001. Anyway, I'll use S for scripts, R for reports, maybe F for figures, but that's really up to you. Yes?
Can you repeat the file name?
So I called it S01, S for script, but feel free to call it the way you want. S01 and then dash, something super important. Never use spaces in your file names. Yes, very good. I like that. I like underscores. Now, you can use spaces in your file names, but you will not be allowed to use spaces in your variable names. Okay, so I called my first variable x and y. I could not call a variable my variable with a space between the y and the v. Okay, so it's good to avoid spaces when we name anything. So I called it S01-startr.r. And so what I'm going to do from now on, so I can minimize this and minimize this one, is that I'm going to type everything in here. So for example, x, I'm going to assign 11. And then I'm going to type Control Enter. Or I could actually also use my mouse and click on the little Run button there. But I prefer to use to put my cursor on the line I'm interested in and then type Control Enter. And this will automatically execute what I have here in my script in my console. Okay, so it's essentially the same thing as me selecting, copy, paste, enter, but I can make this much more efficient by going on the line of interest and type Control Enter, and it will automatically execute that line of code in my console here. Okay, and now x has value 11.
Is that affected by where, if you have multiple lines of code, where your cursor currently is?
Yes, so if I have, here, okay, x is 12. If I'm here on line 1, let me change this value. If I'm on line 1 and press Control Enter, then it's line 1 that is executed. If I'm on line 4, then it's line 4 that is executed. I could also select a whole chunk of lines and press Control Enter, and then all these lines are going to be executed. So Control Enter is really useful to make it easier to execute code. And then if there is something I want to re-execute, I can go up and then enter again. Okay, so that makes this interaction with the command line much easier. Yes?
So you put 10 and 12 in the same variable, right?
Yes.
Why did it update? Why did it print both 10 and 12?
So, okay. Let me re-execute just to make sure that I'm going to remove this. X is 1. Y is 1. So I'm going to take everything here and execute it. So a volunteer, what's the value, what's the content of the variable x? 12. What's the content of variable y? Okay, and now I'm going up and I'm going to execute line 3, Control Enter. What's the content of variable x? 1. Yes. And so the variable has only one content, and when I reassign it, I basically erase what there was before and replace it with the new content. Okay, does that answer your question?
No, sorry.
Or why do I do that?
No, if I ask what is the value of x, so
Yep.
will it be 10 or will it be 12? If I ask what the variable x?
So if I don't know, I type x,
Yeah.
enter, and that means give me the value of x.
We have a 12 also in there.
Pardon, we have?
We have a 12. The last line.
That's because I executed line 3 after executing line 7. Okay, so this is a script, and if I execute the script line by line, at the end, x will have value 12. But if I execute something else in the console, then x might have a different value. So very often when you try things, you might try them here, and then once you are happy with what you have done, then you would type that in your script, and that's your record of what you have done, what works, what you're happy with, and what you might potentially share with your collaborator or with your future self. Okay. What's the value of x now? 4. Yeah. So we can have calculations, operations, and then assign the results of these operations immediately in a variable. Okay. And now if I type x times 2, what will be printed out on the console if I only execute this? 8. Yes?
What would be the reference type for these variables?
What do you mean by reference type?
As in, like, would it be considered like an integer, or would it be considered a double?
Very good question. Let me get back to that in a second. So the answer is 8. But actually, the real answer is twice the value of x. Right? Now, you told me 8 because you remembered that before I took assigned to x 12 divided by 3 and so on. But let's not forget that R is here to do the calculation for us. You know, it was a relatively simple calculation to do, so you all did it kind of in your head and gave me the answer. But most of the time, the reasons we are going to use R or any piece of software is because the software is much better at doing the calculation. So what we need to be able to do when you read code is to reason on the code. Not to do the calculation for R, but to reason. And the kind of reasoning is, whatever I had before with x, now I'm going to have twice that value. Now again, this sounds pretty trivial, but I'm going to repeat myself a lot during these 2 days to kind of reinforce some concepts. And one is to be able to reason on the data. One of the reasons you might want to use R rather than, for example, Excel is because the data is too big. It doesn't fit in Excel, or it becomes very difficult to manipulate the data in Excel. But if the data is too big for Excel, we can't expect to be able to see the data unless we visualize it, of course. So how can we work with data that we cannot see? We need to be able to reason on the data. There are some requirements, some expectations that the data needs to satisfy. And once that's the case, we can manipulate it without looking at it. And that's the kind of things that we're going to see tomorrow. Okay, I think we did all this. Very good. So you had a question. Yeah, I'm going to answer your question now. So let me execute this thing here. So now, yeah, we get 8. So your question was, what kind of thing is this value x? And we can ask about it. So, and the way we ask about this is to say, what's the class of x? And it tells us it's numeric. It's a number. Now, if we have numbers, we also have other things. And these other things could maybe be, let me create a new variable. And this variable, now I'm going to, on purpose, try to confuse you. Right. So, what's the content of variable y? Yes. It's not the number 12, but a string value. And so let's look at, or let's ask, what is the class? What's the type of variable y? And we do that, it tells us it's a character. So we're going to see this later, but it's important to make the distinction between numbers and characters. Okay, for a computer, these are two different things. And we can say x plus 1. Yeah, no problem. But we cannot say y plus 1 because y is a number. Okay. And even though it looks like 1, this is because we are intelligent beings and computers are fundamentally stupid. So for a computer, this is a character, and although it looks like a number, it's not. And if we try to take this character and add 1 to it, we get an error. And I'm sure we will get many more errors in these 2.5 days. But that's good. So having errors is not a bad thing. We all hit errors. What is actually very difficult is to be able to decrypt what does this error mean. Okay? So error in y plus 1 non-numeric argument to binary operator possibly sounds like Chinese. I don't speak Chinese. Some people speak Chinese, so maybe it sounds like French to them. So it's very difficult to understand really what it's trying to tell us. It's telling us that we are taking a binary operator, plus is an operator that takes two values, and one of its arguments, in this case y, is non-numeric. So we're trying to add two things, and one of these things is not a number. So that is certainly one of the difficulties in learning R and probably any programming language. I don't think that the errors in Java are much more easy to understand. Being able to understand this new type of language is sometimes difficult. But here we go. We have our first error and trying to make sense. So whenever you have errors, that's fine. Of course, we are here to help you, but try to read the errors. And the first time they will probably be very obscure, but reading the errors and then remembering, what went wrong when I had this error. Very often it's the same type of errors that come up over and over again. So there is this, let's just, let's do this exercise together. F mass underscore index, okay. So here's a little exercise. What happens here on this line? Anyone? What happens on this line? A little bit louder.
Mass value being initialized to a double integer.
So mass value is being initialized. Yes, if so. Let me decompose this. First of all, do we have a mass variable that already exists? If not, we are going to create it, and that's what initialize means. And then we are going to put 47.5 inside it. So what I'm going to try to do to you is to verbalize some of the code that we see. And the code is going to become more and more complex, and I think by the end of today, we'll already see some confusing code with funny characters, and I think you'll start to wonder, was it really a good idea to want to learn R? But I'm going to try to make you verbalize this code. It's very important. So when you learn a programming language, as opposed to other kind of real languages, how do we learn to programming language? By writing the language. But if you learn French or another language, you probably started to learn it by kind of reading or speaking it. You didn't start learning English by writing. You first verbalized it. So it's a little bit weird in programming, where we learn the language by writing it instead of reading it. And it's a really good thing to learn a programming language to read code, even before writing it. Writing is much more difficult, much more frustrating than reading it. And so verbalizing what you see is a good way to familiarize your brain with this kind of weird signs and structure. Okay, so here second one, somebody else, volunteer. Otherwise I'm going to have to, when I teach, they all have numbers on their computers, so I can use R to pick up a number at random, so I don't make any enemies. But that's not possible here, so I'll have to. Yes, you look at me with a big smile. So yes. Could you verbalize what happens in this second line here?
We link the number 122 to a variable that's called age.
Okay, yeah, we'll link or we assign. Very good. Right, third one here. Somebody else? Don't look at me, don't smile, look away. Would you want to have a go?
Take the value we assign to the mouse times 2 and assign the new value we get to the new mass.
Okay, yeah, very good. So we first, is this going to work if we type it as it is in our console now? So I'm going to show RStudio here. Here it is. I'm going to show you a new command, ls, with parentheses. And ls stands for list, and it lists all the variables that I have created so far. So in this session, where I have variable x and y, would I be able to run this command? And if you don't know, feel free to try it in R. So I see quite a few people saying no. Who said no? I don't remember. Okay, why is it not going to work?
Because we haven't defined mass in R.
Exactly. So what is R going to do is say, oh, I need to assign something to mass. Very good. What do I need to compute before assigning it? Taking the value of mass multiplied by 2, and that's where we would get an error. Exactly. So this would not work if we did not have a mass variable before, but we have it here. So what will the variable mass contain after executing this line of code? Twice the value of before. I could make the calculation, but on purpose I'm not going to do because I don't want to embarrass myself in front of you. But that's R's job, right? R is there to do the computation for me. Yes?
Are the variables case sensitive?
Yes, absolutely. A very good question. And let me demonstrate this here. If now I have a capital X equals, 100, right? Small case x, capital X, completely different things. Yes. No, here. Right. And so same thing with age. We take the previous value of age, we subtract 20, and then we update the content of this variable age. And here we create a new variable called mass underscore index. So again, no space. And there are two or three or maybe 4 ways, schools of how to name variables. Of course, everybody has an opinion. So mass index, everybody agrees that this is not possible. I cannot, let me move this at the top here. So mass space index is not possible. I cannot create a variable with a space. So if this doesn't work, what we have seen in the slides is to use an underscore. And that's called snake case, because it looks like a snake with underscores. Okay, there is another way where we would use an uppercase to separate the words, and that's called camel case, because it's like a bump on a camel. Who said that programming is not poetic? And then there are other possibilities, just like this, all lowercase. That's maybe a little bit difficult to read. And another one that I advise you not to use, it would be to use a dot to separate the words. Okay? It's better not to use this in any programming language because it can be confusing. Other programming languages, it means other things. And sometimes in R, it has a special meaning too. So here are 2 options, snake case or camel case. Again, pick the one you prefer and ideally stick with it within a script so that it makes it easier for you to read and understand the code later on. So here we are. So we create a new variable mass index, and we take the value of mass, and we divide it by the value of age, and assign it. Okay. So I'm going to delete this. Good. So what we have seen so far is a very, very important concept, which is the concept of variable. So we're going to see something else now, and these things are functions. And we're going to test it with a new function here, round, for example, 3 point, right. So a function is, in R or computer languages, is like a mathematical function. It's something that does an action, and to do its action, it takes an input, and the inputs come within the parentheses. It takes that input, it does something with it, and then it returns an output. And in this case, round takes numbers, and then rounds it and returns the round value. So of course I could for example, I could use this function and then calculate something with an input and store it immediately in a new variable. And here did I not execute this? Here we go. Z. Yeah. This is going to happen very often, mixing the control and the caps lock. But here we are. So now Z contains value 3. But that sounds a bit, looks a bit extreme, right? If I give it 3.1265 and so on, and rounding it returns 3. So there is a way to parameterize the way this function works. And how does it work? Well, when we don't know, there is one thing to do, is to go and check the documentation of a function. And to read the documentation of a function, we can use the question mark. So the name, keyboard shortcuts. Look, I start typing round, R-O-U, and now RStudio is automatically going to come up with some suggestions that start with R-O-U. And the suggestion I'm interested in happens to be the first one, so I can press Tab, and then it will autocomplete to the very end of this word that is of interest to me. Again, that's also a useful shortcut to minimize the typing. Yes?
When you rounds a variable, does the value that gets output from that get stored back into the variable?
No, but that's a very good question. So let's look at x is now 1 point here. So I'm going to assign this to x, and I'm going to show here, so we can see the value of x here at the bottom. So if I run round x, the output is 1, but the value of x hasn't changed. Okay. And so if I want to change the value of x, then I would need to run it like this. I take x as input, I compute something with x, and then I override the content of x. And that's always how things work in R. Okay. We do not automatically update variables unless we explicitly override them. Okay. So we would like to learn a little bit more about the function round. So how can we do this? By reading the documentation or the manual page. And this can be done with question mark and then the name of the function. So if we do this, the documentation page opens up here. And chances are the first time you read this documentation page, you will not understand very much. And that's somehow a feature of the documentation page, because this documentation page has to be technically very specific and accurate. So it's really meant for people that already know what the function does, unfortunately. But we will learn how to kind of go through these documentation page and how to spot the most important parts that will help us to understand what the function does. So these documentation pages always have a title, a description, a usage section. And so actually here we ask for the documentation of round, but we get documentation of ceiling, floor, trunk, round, and signif. Arguments, which I'm going to come back to in a minute. Arguments here, detail section, and lots of things. And then at the very bottom here, and that's probably the most important section of a documentation page, and you will find is for every function, is a section with an example. So very, very often when you hit a new function and you want to learn about it, my advice is look at the documentation page, quickly read the description, and if it's too technical, if it's not well written, if you don't understand it, it's not your fault. It's the fault of the person that wrote the documentation, and they didn't have the beginner in mind, but they had the kind of expert user in mind that has already some technical knowledge. So if you don't understand, it's not your fault. But go to the very bottom and try to play with these examples to get an intuition of what happens. And again, the examples should be easy enough to understand what happens. Sometimes they are not. And once you get an intuition about what's happening, you can then come back at the top and read the description again, and then it starts slowly to make sense. Yes?
Mine is a quick question. In my environment, let's say I decide I no longer want X, I want to see X.
Okay. Yes. We can use another function for that. And the function is rm. So Control L. ls lists all the variables that I have. If I type rm, and for example, the capital X, and now ls again, capital X has disappeared. So I can use rm to delete a variable. There was another question?
Oh no, I thought you were pointing at me.
Oh, okay. Yes?
To delete everything, just...
Yes, so if you want to delete everything, there is a little button here, the little broomstick here that deletes everything. But you can also do it using R code. ls lists all the variables. rm deletes variables that are passed as input. So we can also say rm, what do we want to rm? Everything. It's actually slightly different. We need to say list equals ls. And now we delete the list of all the variables. But if you use RStudio, you can also use that button.
Does this remove everything from current memory? Not just from the...
Yes. R has what is called a garbage collector, and it's going to clean up or free up. It's not going to erase the memory. It's going to cut the link between what you had in your workspace and the memory. And once there is no such link anymore, it means that the memory can be reused. So R handles this automatically. So let me get back to my round documentation page. And so if we look here at round, we see in the usage section, can you read this? Yeah? People at the back? I can try to make it bigger. I'm not sure if I'll succeed. But so I read here that the usage of my function round is x, and then there is something else with digits equal 0. And so these are the two possible inputs to the function round. X here is a numeric vector. So now I'm just reading here what a description of these arguments. Arguments is another word for inputs. X is a numeric vector. We have seen what numeric means. It's a number. It's not a character. And the vector is x, for example. X and y, that we created these variables of type vector, of length 1. Right? Or something else. Or complex vector, we don't need to know that. And then now digits, right? Digits also happens to be an input to round. It says an integer, so another number, indicating the number of decimal places. And if we say here digits equal 0, it means that by default, if I don't specify digits, it will say 0 values behind my dot. Okay. So now that I have seen, I've read about the documentation, I have seen that there is this x input. That's the first one that I use, but also digits that by default has value 0. I can now rerun round x and try digits. Digits equals maybe 3. Oh yes, I deleted my x. Okay, by default round. Here's my x. By default round returns 0 digits. If I now specify digits equals 3, I get an output with 3 digits. And I can use it like this, where I spell out digits, but I could also simply say round x3, and then R will automatically know that my first input here, that I happen to call x, but it doesn't need to be called x, like here, okay? That's just random. But it knows that, so the first input is mapped to x, and the second parameter here is mapped to digits. So this is how we use functions and arguments or parameters to our functions. Okay. Any questions so far? No, you already had quite a few questions, which I'm very happy about. Oh, yes.
Returning to the previous one where we have assigned y a character like double quotes 12. So we know that it's a number, but the R doesn't know it. Can we make R to recognize it as a number?
Yes. So we had the following use case where y contained 12, or you can use single or double quotes. Okay. So here we are. Y is, and we can even check this. Right. Okay. Is a character. So there are a whole set of functions that start with as dot, and you see here as dot lots of things, but the one I'm interested in is as dot numeric y. And this basically tells R, take y, and whatever you have in R, force it to be a number. Now it happens that now, this was the character 12, that looks very much like a number. But if I try to say as numeric, and then, for example, I said A, here's what I get. A warning message, so this is not an error, it's not a fatal problem. If there is an error, it stops. Here it only warns me, and it says NA, so NA stands for not available. It's a missing value. And we know missing values in proteomics, right? NA is introduced by coercion. Coercion means when you convert something from one type to another. And so we ask to convert an A to a number, but that's not possible. So what we get as output is a missing value in NA. Okay. So it's possible to do these conversions, but sometimes they work. And most of the times, this is an exception. Okay. Most of the times, these conversions don't work. And so we have seen as numeric, but there is also as character. And actually, as character always works. You can take anything and convert it to a character by quoting it. So an as character is easy to do. But converting a character to a number is much more difficult. It will only work in a tiny number of cases compared to all possible characters. Good. Actually, with your questions, we are already addressing some of the exercises that were meant to be done later. Okay. So what we have done so far is that we created vectors of numbers. Here, x is a vector with a number, only one. Y here is a vector of characters. But we can create longer vectors. And we can do this with, I'm going to call this pap length. And let's assume that I'm going to store the length of 3 peptides for a start. And I can concatenate or combine these values with the function C. So if I say function, you must expect to see parentheses. Okay, so you have, I didn't say this. When you have a function, you have the name of the function. And right after the name of the function, you have an opening parentheses and then a closing parentheses. And then between the parentheses, you have these inputs that can be optional. Alas, for example, we used without anything within parentheses. So we use the function without parameters, without arguments, without inputs. Okay, so here we're going to use the C function to concatenate, combine. And for example, let's imagine that I have 3 peptides that have length. They are, of course, too short to be really useful, but it's to save some time being. I store the length of 3 peptides, 4, 6, and 3, and I store this in a variable called pep length. Okay, and here we are. Pep length contains 3 values, 4, 6, 3. So what type of variable is it? Pep, tab. So you see I start typing pep, and then I use the tab key to autocomplete. It tells me it's numeric. Indeed, these are numbers. But the difference with X, or what we had before, is that I can now also ask, well, what's the length of this pep length? And it tells me, let me clear my screen and run this again. Okay. The class is a numeric, and its length is 3. Okay. So vectors are either characters or numbers, or actually they could also be complex numbers or logicals. We're going to see that later. But all the elements of a vector must be of the same type. And so this vector is a numeric vector of length 3 because I have 3 elements. Okay? So let's create a second vector. I'm going to call it, yes?
Do vectors have indexes?
Yes?
That we could be able to reach individually?
Yes, we are. I can show this now. So pep length has 3 elements, 4, 6, 3. How do we access the first one? By using a new type of cryptic character, which is the square bracket operator. So if I want the first element of pep length, I would use 1. Pep length 1 will tell me, go and fetch the first element of this vector pep length. If I wanted the second one, 2. If I wanted the third one, 3. Okay. Now, if I wanted the last element, how would I do to get the last element of pep length? So don't rush on the first answer that you would do because you are clever. Right, you know pep length, you have seen it, and so the first answer would probably be this. But trying to reuse something that we have seen just above, how would you do to fetch the last element, not only of pep length, but of any vector called pep length? How would you do that? Very good. I should have brought lollipops. Right. This here will always return the last element of my vector pep length. Do you see and understand why? Does anyone? Okay, yes. Yellow, no. Green sticky notes if you understand why this will work and always return the last element. And red sticky note if you're a little bit confused about these cryptic characters, which would be perfectly normal. Okay, now I am confused because I see one person that has a green and a red sticky note. Okay. It's a good opportunity to repeat myself and say that before writing code, it's important to familiarize yourself with the reading of the code. And that's something I only learned after many, many years of programming myself when my own children started to read at school. And so how did my children, there are different methods how to learn to read, right? But I don't remember how I did it, but I know how my children learned to read. And so they were not given a kind of a long text. So here, Matteo, read. Right, that's not how it works. We first give them small bits to read, and they were phonemes, kind of cryptic signs, and they had to memorize if they see this cryptic sign, right, or this cryptic sign, they had to realize that they need to say ah. It's an A, but they didn't say learn A because we don't pronounce an A, we pronounce an A, ah. Okay? And then they also had to memorize that if they see this cryptic sign or that cryptic sign, they should say t. And I also learned that if they see either that cryptic sign or that cryptic sign, they should say k. Right? And then they were shown the following set or combination of cryptic signs. And they had to remember, oh, I have seen this. That's k. I have seen this. This is oh, and this, I remember, this is t. And then they had to do something very difficult, is to combine these three sounds to make cat. Well, this is exactly the same thing that you have now to learn. Of course, they had a lot of time to do this very difficult process. You have 15 minutes left to do it with the R language. So let's try to do it for this line of code here on 49. And what I'm going to do is I'm going to add spaces. And that's perfectly correct R code. You can add spaces. I'm not going to add too many here. That's perfect R code. You know, we can run it. But let me also add one here. So how do you go when you see some cryptic characters? You need to find anchor points, things that help you to decrypt this line of code. And one of these is the parentheses. I told you when there is a function involved, you have the name of the function and then opening parentheses. And then some input to the function and then closing parentheses. So with this piece of information, you will be able to decrypt this bit. Okay? So this bit, even if you don't know what the function length does, even if you don't know what the variable peplength is, you know that we call a function length, and that input to length is peplength. If that's all you know, you read up the documentation of length, and then you learn that it takes a vector as input, and it returns length. So now we know that this is going to return a number corresponding to the number of elements. Your second anchor point is this thing, the square bracket operator. We have just learned that this is the operator that we can use to access elements within a vector. Okay? And so what's the name of that vector? Peplength. So again, we have no idea what's stored inside peplength, but we know that we are going to access some element inside peplength. Which element? The last one. So when you see this long string of cryptic characters, you need to learn to read R. I think that's a good way to start. And how do you do that? Identify specific characters and deconstruct, identify the subparts, and then reconstruct everything. Like my children did a couple of years ago. And I only realized that that's how you read code when I saw my children learn to read. So that answers your question, how can we access different elements? And I'm speaking too much. Let's create a second variable. Now let me see. Actually, we have already done quite a few of these things. Yes, so we have peplength here that contains, I don't remember, contains 463. So here's an exercise for you. I would like to create a new variable, peplength, that contains 4463. How could I create a new variable that I would call, for example, peplength2, and it contains 4463? Sticky notes down and put them back up once you have found an answer. Bonus for this is try to reuse what we already have, and that is the variable peplength that already contains 463, but I would like this new variable to contain 4463. How would you do that?
Please repeat the question, please.
So I would like you to create a new variable called peplength2. I mean, you can call it whatever you want. And this one I would like to contain 4463. Okay? But I would like you to create this new variable that contains 4463 not from scratch like we did for peplength a little bit up here, but reuse what we already have. And what do we already have? Peplength that already contains 463. So could you create this new variable paplength2? And don't forget your sticky notes once you have the answer, or a red sticky note if you haven't understood the question or if there is something more fundamental.
4463 is that a vector? Is that
That's the content of this new variable called paplength2. And yes, paplength2 will be a vector of length 4. So a hint for those that haven't finished yet, we have used the function c to create our first vector, paplength. So you'll also need to reuse the function c. But now the big question is, what are we going to put inside the parentheses?
What is the function C stand for?
Combine or concatenate. So let's try to do that together. So I'm going first to give a not so good answer, and then I will count on you to improve it. Okay? Actually, here's my first answer, and I will. And as you can see, RStudio shows this little mark here that tells me that there is something wrong with this line of code. What's my mistake? Yes?
No commas.
Yes.
No, there's no commas.
Exactly. So this means, what do I need to concatenate? Well, 4 space 4 space 6 space 3, and that's not correct. I need to concatenate 4 values, 4 vectors of length 1, 4, 4, 6, 3, like this. Okay? So this works. Okay, let's see here, paplength. So I get my result, but I'm not really happy with the way I got it. So it's possible to improve on this. And now I will ask somebody to help me. How can I improve on this?
C4, comma, and then
Very good. That's exactly what I wanted. Here I'm going to replace this by the content of paplength. And I'm missing an S, yes. Okay. And indeed, it's exactly what I have. Okay, so I'm reusing a variable, and I'm concatenating 2 vectors, one vector of length 1, only 4, and this other vector that contains 4, 6, 3. Yes, excellent. Yes?
What if I wanted to insert something which is not conveniently at the beginning?
Very good. So what we are going to see now is how to create a vector of consecutive numbers. So if I type 1 column 2, I get 1, 2. 1 column 10, I get 1, 2, 3, 4, 5 to 10. And I could say, many zeros, and R is going to create this really, really long vector. And the element, the 961st element is 961, and so on. Okay? So now, look, I could say, let's say, I'm going to clear my screen here. Paplength has 4, 6, 3. And let's imagine I want to have 4, 6, 1, 3, reusing paplength. So here we go. This one. Okay. So what am I going to put inside here? Well, I'm going to concatenate things. The first one I'm going to concatenate, actually I could also type 1, 2 here. Okay, so if I execute this, I get my first element and my second element. I can also type paplength and my third element. That gives me 3. So I told you about the column here, but we don't really need it. We could say 1, 2, or we could use 1, column 2 like this. Right? So this has the 2 first elements of paplength. This has the third element of paplength. So I can take all of these things and combine them. And I don't remember what I said. I just say 10. Okay, and so now I create a new vector by concatenating 3 vectors. The first vector contains the 2 first elements of pep lengths. The second vector is a vector of numerics of length 1. And the third vector is pep length, but the third element. And that's how we could do it. As you can see, it becomes long and even more cryptic. But if you remember that the parentheses is, separates the name of the function from its input, we see that we combine 3 vectors and so on. You can decompose this command, and start to make sense out of it. And when you become fluent with a programming language, reading this will become easier and easier. Let's do a little exercise, and the exercise will be is here. So, what are we doing here on this line of code, where we create this num_char variable? What are we doing? Can anyone verbalize what's happening here in this line of code? Yes?
Creating a vector with different references as if we're like integers and the string value.
So what are we going to have in this vector num_char?
Character value and numeric value.
Ah, okay. So character values and numeric values. Any other options? What else could we have? Well, you know what? Try it out. Type this line of code, create this num_char, and then what function can you use to query what kind of variable this is? What's the name of that function? Class. Could you please try it out and tell me what's the class of num_char? So, according to the, I'll let you finish your exercise. So could you put your green sticky notes up once you know what the class of num_char is? And I see Mina standing there looking at me, telling me it's time to stop. But no, I'm not going to stop. I'm going to hold you here until 6 o'clock because we all like R. No, I'm not going to do that. But I'll give you a little bit more time to kind of figure out what the class of a num_char is. Okay, you get a second chance. What's the class of num_char?
It's a character.
It's a character, yes. And that's one extremely important property of vectors. And we're going to see this again tomorrow when we start to tackle bit meaty data. A vector contains a certain number of elements. It could be 0, it could be a million, as many as we can fit in memory, more or less. But all these elements must be of the same type. So if we concatenate numbers, and characters, implicitly we will get a character because we can always convert anything to a character by adding quotes. Okay? So if true is a logical, and there is true and false, but all capitals, that's very important. And false, true is a true statement, false statement. So what happens if we combine numbers and the logical? Let me quickly show you here. Okay, if I have true, it's a special word that means true. And if I type class of this, okay, it's a logical. So it's a vector of logicals of size 1. So what happens, and where is it here? So what happens if I concatenate numbers and logicals? What do I get as output?
Character?
A character?
Yeah.
Okay, maybe.
You can't mix.
No. So if I take numbers and logicals, everything is converted to a character. Try out. Try it out. Or somebody else can have another suggestion. It says numeric. Okay. So we can convert. And so what's written there instead of true? If you run this line of code, and you can try it with only 1 and true to save you some typing, what's the content of num-logical? Let's try it out. Control copy. V here. So the class of num-logical here is a number, numeric, num-logical. So my true has been converted to a 1. So it's possible to convert a logical to a number, and so that's what is done. Okay. Yeah?
Would true always become 1? Or is it just because the first number is 1?
Oh, I see. Let's try it out. Let's give it a 10. It's still a number, and true is converted to a 1. So let's try now to add false to it. Still a number, and the false is converted to a 0. Okay, so a true is converted to a 1, and the false is converted to a 0. Yes?
Is there a way to see all the types of classes that are there?
I don't know if there is a way to see them all, but what we can do is to look at notes here, and here I list those that we generally find. So we have numerics and characters, the ones that we have already seen. We have logicals, true and false. Very careful, true and false capitals. Otherwise, it's something else. Otherwise, it's a variable name, and then it'll complain saying, oh, I don't find any true and false variable. So we also have integers. When we have integers, a special kind of number. Again, R will convert integers to floats, all for us. We don't need to worry about it, but it's there. We can also have complex numbers and raw binary data. So these are the type of factors that we can have in R. So let me, however, also look at this example here, where we now try to combine characters and logicals. Again, we can always convert anything to a character. So as soon as you have one character in your vector, everything will be converted to characters. It's kind of the most generic way of representing data. Okay, so it's 5:05. In the schedule here, it says that at 5 we have a Q&A. That really is meant to last until 6 o'clock. Now, it's weird. They say it starts at 5. They don't say at one time it finishes. So is it for me to decide? No. So it's up to you to decide. So we haven't quite finished everything that I wanted to do today, but it's not a race. Okay, we are not here to win the competition. What's much more important is to understand the basics, and then we can move on and build on more kind of complex data analysis. But there are still a few things that I wanted to see before moving on to the data analysis. So of course, if you have questions, you can ask questions, but I think you have been really interactive, and that's really nice. But if you have time, I don't know if anyone needs to leave now, but we could keep on for 5 or 10 minutes or so, if you are okay with that. If there is one veto, one red sticky note, we stop immediately and I leave. But unless I see a red sticky note popping up, I suggest we continue for 5-10 minutes to see a couple of other things that will be useful later. Yeah? Is that okay with everybody? But feel free, of course, to ask questions, and I'll try to answer them. Let's see. Okay, good. So we have actually... I'm going to Control copy this. No, that's not the one I needed. Okay. So I had peptins, and here I have a vector with a couple of peptides, of peptide sequences. Okay. So this is a vector of characters, and its length will presumably be 4 because I have 4 characters here. Okay. So something that we have already seen, thanks to a very good question, is how to access single elements, PEPs, or actually a set of elements, and how can we do this by creating 3, for example, and 2. Okay, to create a vector of indices, I want the first peptide, the third peptide, and the second peptide, and this will now return my first peptide, my third peptide here, and then my, what was it, this one, my second peptide here. Okay. But there are actually more interesting ways to do all this subsetting. And to illustrate this, I'm going to recreate here my PEP lens, but I'm going to make one up as I go. 10, 5, 6, 7, 50. Okay. So I create this vector of numerics. It has a length. I don't know which one it is. If I needed to know the length, I would not count them, but I would type length PEP lens. And so what we are going to see now, and that's really important. That's something we're going to reuse tomorrow. Yes?
Can you pick one amino acid from the first peptide?
Pick one amino acid. Yes. But I'm going to show this afterwards when we finish in the question, because we will need to see new functions, and that it would take. It's not difficult, but it would be a bit convoluted. We can have a look at this later. Because this is a character of length 1, right? This peptide. It's not a character of length 1, 2, 3, 4. No. So we need to kind of split it. But so what we're going to see now is conditional subsetting. What did I say? 10, 5, 20? 30 minutes, right? That's what I said. What we're going to see now is something called conditional subsetting. So let's say, and that's a very relevant assumption, I'm not interested in peptides. I have run this acquisition. I have peptide. I have PSMs. I have peptides. But generally, peptides that are too short, I want to disregard. Okay. So let's assume that these are length of a set of peptides that have been identified, and I want to get rid of all those that are too short, and I will define too short by smaller than 10. If it's smaller than 10, or even 10, I want to get rid of. How could I do that? I can use the following operation, PEP lens greater than 10. What's going to happen? And actually, I said I would answer your question before when you used PEP lens plus 4. Okay, this is exactly the same type of reasoning that the example you had. So what happens if I ask PEP lens greater than 10? What's the length of PEP lens? I don't know, let's say 7. So now I ask the following question. Something that has a length of 7 is greater than 10. So what's R going to do? Let me clean my screen here. What R is going to do, it's going to do this comparison greater than 10 with each element of PEP lens. So my first element, is it greater than 10? So exactly, R doesn't know yet. R knows true. What about my second element? Is my second element greater than 10? True. The third one, is it greater than 10? True. The fourth one, is it strictly greater than 10? No. R doesn't understand, nah. False. And then false, 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 true. So let's run this. So what do I get when I type PEP lens greater than 10? What do I get? Very good. A vector of logicals. What's the length of this vector of logicals? That's what I wanted to hear. The same length as PEP lens. That's all I need to know to reason about my data. I don't care about the actual values in pap length or its length. I just need to know that these are numbers, otherwise greater than 10 wouldn't work. And then I let R do the rest. I know I have a vector of numbers of a certain length, and I know that my output is a vector of logicals of exactly the same length by definition. Now we haven't seen, so we have seen the subsetting with numbers. We haven't seen the subsetting with logicals, but we are going to see this now. Let me type this in here. So I have paps, 4 values. So what if I wanted, the first and third value? I could type paps C 1, 3. Okay, so this works. This is what we have seen. But we can also do something that initially will look a little bit weird. I can also do the subsetting with logicals. C, true, false, true, false. Do I want my first element? Yes, I do. Do I want the second element? No, I don't. My third one, yes. My fourth one, no. And this is what I get. I get the expected result. Now, typing this is long and convoluted. But we have just seen that we can compute these vectors of logicals based on this comparison. So if now I asked you, how do I get from all my pap lengths only those that satisfy this condition, how would you do it? No. But you get the idea. Yeah. You don't know the syntax yet. That's fine. That's why we are here. So, what's the vector that I want to manipulate? Pap lengths. Okay. How do I do the subsetting of a vector? Brackets. I call this square bracket operator brackets. Yeah, parentheses. Yeah. And how would you call this thing? Curly brackets.
Braces.
Pardon?
Braces.
Braces. Oh, okay. I have lived in the UK for many years, so braces are suspenders. Okay. But we do understand each other. Right. So whatever this cryptic sign is, to do the subsetting. Now, what subsetting do we want? We want the elements that are greater than 10. How can I ask this question? Here. What elements of pap lengths are greater than 10? That is exactly how I asked the question. So I'm going to copy this and paste it inside here and execute this. And here we go. Okay. I want to do the subsetting. How do I want to do the subsetting? Using logicals, a vector of logicals that I'm going to compute. Oh, actually, I'm going to ask R to compute automatically for me. And the reason this works is because the length of this will have the appropriate length by definition. Okay? This is the kind of reasoning on data that we want to do in R. We don't want to look at the data. We could do it here, it's small data, but as soon as it gets big, it's impossible. So we need to kind of let go and be happy with not seeing the data, but reasoning on the data with this kind of requirements. Okay. So we could also combine these expressions. For example, we want peptides that are greater than 10 and, let's say, smaller or equal than, I don't know, 20. So here I kind of combine greater than 10 and smaller or equal than 20. If this looks cryptic, let's try to decompose it. We have seen here that greater than 10 produces a vector of logicals. What happens if we ask pap length smaller or equal than 20? What is going to produce? a vector of logicals. Here we go. So we have two vectors of logicals. And we are going to say first vector of logicals and second vector of logicals. What is R going to do? Is going to do this AND operation element-wise. True and true is true. True and false is false. True and true is true, and so on. We probably have we don't have a false and false, but false and false is also false. So R is going to compute this first set of logicals. Second set of logicals, do the logical operation AND to produce a new vector of logicals and use that one to do the subsetting. Yes?
Can you put a comma instead of the
Okay. So I'm going to simplify your question. Your question is, can I not type true, comma, false, for example? So what? And you would like this to be a shortcut for true and false. And so how would you write true or false? So this doesn't work. The comma is used to separate arguments in functions. And so, I mean, we could change the R language and say we want now the comma to behave like an AND when there is nothing else. But no, we have to learn that AND has a very specific meaning, and we use the ampersand, and for an OR, we would use the pipe. Okay? But there is another reason. It's that square bracket operators and the comma in between has different meaning, and we're going to see that tomorrow. So this would be valid R code, not for a vector, but for other type of data structures that we're going to see tomorrow. Okay, and so in the notes there are other examples of how to do this conditional subsetting, but we don't need to know for the rest. And so we already saw missing values at A, when we try to to change a character to a number, and we had A, and we tried to say as numeric A, it returned NA. So NA is a special value in R. Here it is. Okay, so NA has this kind of hard-coded value, a meaning of non-available missing value in R. And we can use NA in vectors, for example, vector 2, NA 3, 8 is a vector of numerics of length 4, but the second element is not available. We don't know it. And that has a very specific meaning. Okay? And so to wrap up, I'm going to ask you to create this vector x that contains 2, NA, 3, and 8. And I will ask you to calculate the mean of that vector using the function mean. Okay? Mean is a function. Its name is mean. To use a function, we use parentheses. And if you want to calculate the mean of something, this something you need to put inside the parentheses. So my challenge for you is to calculate the mean of this vector 2, NA, 3, 8. Green sticky notes down and put them back up once you have found the mean of this, or red if there is a problem. And that's the last exercise for today.
In the previous code, so you said like if you do keplins greater than 10,
Yeah.
and would I get a value?
Yeah. So you are asking the following thing. Which peptide length are greater than 10 and smaller than 8? Is that even possible?
Okay.
Yes.
You take this as an answer?
Right. So
That is the... okay. So somebody has an answer, and you type the following. Mean x, which is the obvious thing to do, And what's the result of mean x? NA. Are we happy with this? No. Oh, you are happy? Okay, well, if you're happy, you can go. Thank you very much. But the majority are unhappy with this. And I agree with you. I am terribly frustrated to go back. Oh, we could say, okay, we stop here and we'll see this tomorrow. No. I am not happy with this. So how can we get around this? There are multiple ways. And I'll give you a couple of more minutes to try to figure out how to do it. Now, what do we do when we use a function and it doesn't quite do what we want? What do we do? Pardon? Yeah, exactly. We look up the documentation. So try to do that. Have you already done so? Oh, you have the answer. Oh, fantastic. Tell us.
So it's mean, parenthesis, x, comma, true.
True, like this?
No, 2 comma after.
Oh, 2 comma. And then?
True.
Oh, sorry, yeah. Like this.
Yeah.
Okay. All right. Yes, but can you explain this to me?
I read in the documentation that the third argument of the function is to remove the NA from the vector.
Fantastic. Well done. So indeed, if we look up the documentation of mean, we see that the first argument is x. That's the vector where we want to do the calculation. The second one is trim. So we can calculate a trimmed mean where we remove, for example, the 5 top percent and 5 bottom percent. And then there is another one called NA.RM. And it says a logical value indicating whether missing values should be stripped before the computation proceeds. So R doesn't take any risks. If there is one missing value and billions of non-missing values, it says, I don't know. Okay? But, as the documentation says, we can say, yes, please do remove NA.RM, RM for remove, true, the missing values before doing the computation. So that's really interesting. It's something that I didn't mention because I thought, oh, we don't have time. But there are 2 different ways to specify parameters. As you suggested, by position. So the second position, let's ignore it. So there is an empty space. And then the third one should be true. There is another way, which I prefer because I think it's easier to read. It's with the name of the parameter. So it's a third parameter, but I can give the name. And then the position doesn't matter anymore. So yes, but these 2 answers are. I prefer the second one because I think it's easier to read. And easy to read code is really important. On the fly, it's fine, but if we want to store something for later, it's really good that it's easy to read. But these 2 are equivalent. Yes. So first, and let me type this in here, because I think that's an important result. So I want to store it in my result file, mean x and a.rm equals true. Another one, has anyone come up with another solution? So we see that the second element is an A. So we now want to calculate the mean of everything but the second element. How can we do this? C, 1, 3, 4. Sorry. Yes, but we want the mean of this. Yeah. We could do it like this. If we know that it's a second element, we could, and that's something new, we could use -2. -2 means every index but the one with a negative value. Okay. And then just to finish on a very confusing note, I could also use a function called na.omit, which means in x, give me everything but omit the nas. Okay. So all these options are equivalent. The nicest one is certainly this one with NA.rm, but there are many different ways to do the same thing depending on our use case and what you think is the easiest at that moment in time. Okay, but missing values, extremely, extremely important for proteomics in particular, but in general. And so whenever you have missing values, many of these functions, mean, median, and so on, max, min, R is not going to take any risks. Okay? So I suggest we stop here. Of course, if there are more questions, I'm happy to answer them. Otherwise, I'll be here at 8 o'clock. From 8 to 9, I think there is a little kind of question and answer. Bring your own data if you have additional questions. But we'll start with the official program back at 9. All right?